Good morning. We're going to start on chapter 7 today. Let me share my screen. Okay, so previously we've been able to do things for grades. This, we'd average them up, total them, average them, and so forth. But if I had a lot of grades, like, 10 or 20 or even 100 per each individual, I'd have to store that many variables down through grade, 10 or 20 or something. And I'd have to manipulate these by knowing all their variable names, which sometimes can get in to trouble if you've got too many of them. So what we're going to pick up today is we're going to start talking about lists. So let's define one for this. All three grades in the same list. I just called it a grades list. And a lot of times people will do this. Either way is fine. I don't have any preference for any of those. Okay. But notice how a list is defined. It has brackets. Now it's going to be important you remember that it has brackets because other constructs have different closing mechanisms. They won't all be brackets. So you'll have to recognize them by what they're using. So lists use brackets. Notice that each element is separated by a comma. And I can have as many as I need. And so forth. Okay. I can print a list. Notice when it prints with the brackets. So I can recognize that it was a list. Okay. Now there's another way to print a list too, even easier. Just use a for loop for X in grades. Or I could have said for grade in grades, but for whatever thing you use here, whatever name you use here, it'll walk through and print each one of those. Now notice that this one prints each one on a separate line because that's what I've asked it to do. Print one, go back and get the other one and print the next one and so forth. Whereas this one printed them all and I knew immediately that they were a list. I won't know that here because they're not in brackets. But they're fairly easy to manipulate. And they're just a mechanism to store things that belong together. It's called a sequence because it has one right after another. Right? Now, the interesting thing about a list is that each of these has a place. They have a position in the list, like this is the first position, the second position, the third position, and so forth. In this list, there are 5 elements, 5 items, 5 things are in this list. They're called elements, basically. Okay? But when you're dealing with a list, each one is in a specific position. And that is, okay, this type of positioning. So here I have a list called my list. It's got 5 elements in it, 1, 2, 3, 4, 5. The numbers 1, 2, 3, 4, 5. But the position of the slot, okay, is always one less than where it is, okay? So for example, a list always starts at position 0. Now these don't have to be 1, 2, 3, 4, 5. They could be like 11 and 2 and, 13 and 42 and 51 or something like that, whatever the number is, okay? You're more interested in right now what the slot is versus how many elements there are. So there are 5 elements in this list. The first element is always at slot 0. The second element is always at slot 1, the third at 2, and so forth. Notice that all lists start with position 0. And they always end with one less than the number of elements. So if there's 5 elements, the last position will be 4. 0, 1, 2, 3, 4. That's 5 slots. They just have to start at 0. So if I wanted to look at my list index 3, that's 0, 1, 2, 3, that's 42. If I wanted to look at my list index 0, that's 11. My list index 5, there is no index 5. This would cause an error when you ran it, and we'll see that in action. So if you try to use an index outside the position that they have in the list, it'll cause an error message. Now, not all languages have lists. Some have what we call arrays, and that works the same. They all start at 0. They go to one list and the number of elements. They index them the same. So once you learn lists and then you go to your next course in Java where it's called arrays, they'll work the same. If I come over to our grades list, I could print grades sub, and what if I did 3 and grades sub 5 and grades sub 6. All right. So if I do grades sub 3, I'll get 0, 1, 2, 3. I get 75. If I do 5 and 6, I'm going to run into trouble, right? Remember, the slots are 0, 1, 2, 3, 4. There is no slot 5. There is no slot 6. So if I were to run all of these, the first one that it tries that's wrong, I get this index error. It'll say list index out of range, which is true. There is no index 5. And then, of course, there will be no index 6 either. Now, the nice thing about lists is that certainly I can put as much in them as I want, but I can add to them. I can keep adding to the list. So let's say that I came in and I said I wanted to append another grade. And then I'll append a 95. And then I'll append if I print grades. Let me take those out. I now have an even longer list. Notice when I appended it appended at the end, and that's fine. There are functions inside Chapter 7 that allow you to append its specific slots. We're not going to worry about any of that. We're just going to append, okay? So all of ours will go to the end of the list and add on from there. Well, now if I were to run these statements, they'd work because I have that many elements. How many elements are in here? 1, 2, 3, 4, 5, 6, 7, 8 elements. So I know out of 8 elements, the last index has to be 7. So all of these are safe now, okay? But anyway, so I can append, I can make things, I can delete from a list. We're not going to worry about deleting from lists. And you can look at the functions that are listed in Chapter 7. Mostly we'll just append and create lists and things like that. Okay. If I had another list, could I can put 2 lists together. Now this doesn't add the 2 lists up and give you new numbers. It just appends these last 2 numbers to the list, okay? So here the plus is not addition but concatenation. Like a string, it just puts the 2 lists together, okay? So I can do that. If I come back in and now I say grades equals, that's a blank list. Notice that I just wiped out everything that I had put in the list because I overwrote it when I said, now make it a blank list. Okay. They're very easy to use as long as you remember this whole business about how they look behind the scenes. Okay. The first index is always 0. The last index is always 1 less than the number of elements in the list. Now this will take you a little time to get used to if you haven't seen this before. Okay. So what we know about a list is it's in brackets and it's mutable. That means it can change. Okay. And somewhere along the line, you're going to have, where am I? There we go. We're in brackets. And lists are mutable. All right. Somewhere along the line, you're going to have a question, I bet, on a quiz. You know, can you change a list? Is it mutable? Yes. Or a list is not mutable. That's false. Okay. So make sure you understand the difference for what a list can do. Now let's take this list we have here. It's a pretty long list now. Actually, let's go back to this list so it's not quite as long. I'm going to open up a new one. What I'd like to do is I would like to add those grades up and average them. Well, you can walk through a list to print it, right? Because we did that over here. So we can use those numbers another way besides printing. We'll just add them up. So I'm going to set total to 0 for X in grades. Total is equal X. And then I have to calculate the average. Total divided by, well, I know there's 5 in there, right? So I mean, I could put 5. But I don't always know that there's 5 in the list. This certainly doesn't tell me anything about what's in the list, right? Or how long the list is or anything. So I need another mechanism. This just adds up the numbers. It doesn't tell me what to divide by. Okay. So I need another way to access the list. What we're going to do is we're going to come in and we're going to say for X in range, okay. Now I know there's 5 of them. Okay. And isn't it interesting that when I do a range in a for loop, it starts with 0, 1, 2, 3, 4, and it ends with 4. So that's interesting. So now I can come in, okay, but I still have the problem of what to divide by. I still would have to come in here try this. Let's say I don't know how many are in the list. I can say, well, give me the length of the list. Okay. Then I come in length of the list. And then what I have I didn't try printing anything. Print average. Okay. Well, that doesn't look good. I know the average is better than 2. Okay. When you do this range, okay, you're counting from 0 to 4. You need to use the index to go with that. Okay. Let's see what we get. 81. Okay. Notice the difference. If I come in and so X in grades, I can add them up, you know, and do that type of thing, because I'm actually saying that X is in grades. So I'm looking at 80 and 90 and 100, so forth. If I do a range, okay, of length of grades, all right, it would still add them up. The total wouldn't work, obviously. But what you want to do then is access each element and total it separately with it, okay? What you're going to want to know is both of them. You're going to have to be able to recognize when both are working, when both can be used, that type of thing. But the nice thing is this is now a piece of code that is generic. I don't care how long the list is. I don't care how many are in it. This will work for any length of list because I'm just saying, give me the length of the grades. I don't care what it is. And it will always do that. Okay. Now between the two, you can mix them up a little bit and do some different things and things like that. We're going to try and keep ours pretty straightforward. Okay. But there are two ways. I can do a regular for X in grades, or I can do for X in range, a length of grades, that type of thing. Okay. I can access it as an index, and sometimes I don't have to access it as an index. That's up to whatever you're trying to code. Okay. But even easier than that, okay, I could do okay, we have a function that'll sum up a list. Okay. If I don't tell you, you have to write it out, then you can use the sum function. But if I tell you you cannot use sum, then you'll have to write it out the long way. All right. But there's built-in functions like this. There's sum, there's min, there's max, there's sort, all of those. And you can use those unless I say you can't. Okay. I don't think I say anything about that in the homework. So you should be okay. All right. But notice this is the same algorithm we've been using to add something up. Python probably has an average function too. Okay, it has lots of them. I'm not sure it's listed in the book though. Okay. However, I want you to know how to do it the long way as well. Okay. Okay. So we can certainly add up a list and things of this nature. All right. Let's try a different type of list. Let's do this one. Let's do an employee equals 1, 40, and $10. This list describes John, the employee that worked 40 hours at $10 an hour. And what I'd like to do is print his name and his pay. Now notice that this list has 3 different types of data. It has a string, it has an integer, and it has a float. This just had integers. So something else we learned about strings can have different type of data. Right? Because here we have 3 different types in the same string. So what I'd like to do is I'd like to print his name along with his pay. So where is his name in this list? His name is in slot 0. So employee slot 0. Sometimes I call it index, sometimes I call it position, sometimes I call it a slot. They all mean the same thing. So that would print his name because I'm asking just for this one thing. And now I want to calculate his pay. Well, that's hours times rate. So I know that hours is in the first slot, meaning one slot, not the first slot, the one slot, okay? And that pay is in the 2 slot. And I can print pay, okay? So you kind of have to know, okay, for these types of things, what's in the slots. Here we knew all grades, all numbers. If the list is varying data types, then you've got to know what are in those slots. Now we saw where I could establish a list as a blank list. Okay, this wipes out what I put in employee. But if I wanted to initialize it to something like all zeros, I mean, I could certainly do this. Zeros. Or I could do this. I want zeros and I want 4 of them. Oops. Or I want 4 of them. So to put 4 zeros isn't much typing. But if you had to do 100 of them, it's much easier to say 0 times 100 than have to put 100 zeros in a list, or any number in a list, or any word in a list. You can do this with a word as well, okay? This is just a short way to initialize a list. It doesn't say give me 4 lists of 0, okay? Well, let me open a new window. It gives me 1 list of 4 zeros. All right, so don't think this is 4 lists. It's 1 list of 4 zeros. So we have little shortcuts like that you can use as well. We don't often initialize our lists for the things that we'll be doing in our class, but it might work in some instances. Okay. Let's try another one. Let's do a cities equals Arlington. Now notice, and you might not have heard it, but when I did that, that's a curly brace. When I did that, initially the idle pinged at me. It gave me that weird, you know, what are you doing? All right, so it'll keep tabs, and when you type it in correctly, then you get that line that shows everything matches. Okay, so I'd like to know if Bedford is in this list. I want to know if Bedford is in this list. So I could walk through the list for X in cities. Okay, if X equals Bedford. Let me take the others out. It wasn't there, so nothing printed. Well, that's easy enough, but I can do it even easier than that. Notice I had to walk through a for loop. I could do this. I could just ask if Bedford and cities. Let me comment this part out. And it's still no because it's not there. But that's a much shorter mechanism than doing all of this. How about if Bedford not in cities? No. And of course it's not in there, so it printed no. So these are very useful to find out if something's in your list. Not in and in. And it works for numbers. I mean, it works for anything in the list. Numbers, whatever you're looking for. Okay. And once you learn not in and length and some other things, they work for other mechanisms that we'll be learning through the rest of the semester. Okay. Okay, so we know how to declare a list. We know how to walk through a list with a for loop. We know what the indices of a list are. And we know how to find out if something's in the list. Now, these are just a few of the functions that you can use. They'll be the ones we mostly use. Let's try reading in a file. I'm just going to create a file. I'm going to call it statements.txt, and I'm going to put something in here. Now is the time. Okay. And I'm going to just call it statements.txt, save as. a text file. Yes, come on. Okay. All right, so I have a file. What I'd like to do is I'd like to read that file in. Now we know how to read a file in, right? You open it up and you read for line in file, that type of thing, and print it and so forth. So there's several ways you can read a file. So let's look at some we've done. Okay, so one, and come in and I can say contents equals in file.read and just print it. And I get exactly what's in the file. Okay. This particular type of read, notice it's just read. We've done read line before, but we haven't done read. This particular one reads entire file as one string. Okay. And the reason it looks like the file is because that string includes a \n on each one of these lines because I hit carriage return when I typed in the file. Okay, but a read, just like this, reads in the entire file as one string. We've done it. Done read line. Okay. And then we'll print the contents. What does that do for us? That reads one line. If I want to read 4 lines, what do I have to do? Well, I can put it in a loop, or I can repeat this 4 times. Right? Of course, when I do that, I get an extra carriage return line feed. Why? Because the file has a carriage return line feed at the end of each line, and I'm adding one for every print automatically. Okay? And then, of course, we've done sorry, we've done the for loop. And you still get the extra line. Okay. Well, there's another kind of way to read in a file. Look at that one. That one's read lines. Okay, that one is read lines. And let's see what we get when we print that out. Okay, so if I come in and I print contents on this one, oh, interesting. I get a list where each line is an element in the list. And also it includes the \n because remember, each line had a \n on it. So if I were to print sub 1, okay, I'd get for all good students. And it did have the carriage return line feed on there because it came down and gave me an extra space. It doesn't print it when it does it. It just does an escape character when it does it like this. Okay. So if I will read in read lines, it will read the file as a list of lines. Okay. So I only had 4 lines in my file, but if there were 50 lines in the file, I'd have a list of 50 elements where each element was 1 line in that file. Okay. So you have various ways, obviously, to read in this type of stuff. Now, let's say that I was going to do this. Oops. Okay. And I wanted to go through and print those. Let's do it for contents. I mean, it's for line in contents. So for each thing in my list, I'm going to print it. And I get this extra space. I want to get rid of that. I don't want that extra line in there. Okay. Here, and I'm going to say something called print R strip. Let's see what that does. Here we go. It takes it away. Now this is a nifty little function. This is out of chapter 8, and it may be mentioned in chapter 7. Okay. But if you leave it blank in the parentheses, it takes out that extra \n, so that the line doesn't have this on it anymore. It doesn't have this on any of these as I print them anymore. Okay. Now that's just for a print. All right. I took it off to print it. You can strip on other things. You can strip on other things in the file. We're not going to do that. That's not what we're going to strip on. We're only going to strip on the \n. Okay. That would be one way to get rid of that extra space in between all these lines that we have. But notice when I come back and I print contents, they're still in the list. Okay. I only took it off when I printed it, but they are still in the list. If I want the list to not have those at all, I need to do something a little different. From every line in the list. Okay, that's what we're going to do now. So I'm going to do the same thing. Let me copy some of this. We're going to read it into a list. All right. And then I'm going to walk for X in range length of contents. So for everything in contents, all right, remember contents is a list. I want to take what's in there in that slot, and I want to so what I'm doing is I'm walking through each line in the list, taking off that \n and putting the new line back in the list. That's what this is doing. So then if I come out and I print contents, let me take this out. It's not there anymore. I took it out. Okay. So what you want to do is you want to have in your arsenal some of these routines. A routine like this, a routine like this that manipulates files and does certain things so that you can pull it up when you need it. Okay, these little algorithms will be things that you'll use even on the homeworks. Okay, depending on what I'm asking you to do on the homework. What if I wanted to take this file and print every word on a line? Right now I'm printing every line on a line. I want every word separated and put on a line. So let's look at how we do that. Okay, I still have to read all of that stuff in. Okay, let me get that. Okay. And print every word on. All right. So I'm going to read it in as a list. I'm going to walk through the list. Okay, now remember, contents is a list of lines. I want for every line in the list. So for this line and that line and whatever, I want every word in line. I want to walk through every word in the line. All right. Let's print word. Let's see what we get. Well, I get letters. I get every letter in the line. All right. Now, word here was just something I used. It's not a built-in function or anything. I could have said W. All right. But let's look at why that is. When I read in a line of data from this list, let's get our, oh, here it is. When I read in a line of data from this list, all right, it has one set of quotes around it, right? One set of quotes around it. That means that it's just one long string. So it went, and in that string, it thinks it's a list. So it just printed N-O-W blank I-S blank T-H-E, so forth. All right. So it simply took a letter at a time because I didn't tell it what things were words. It just thinks everything's letters. I need to tell it where words are. If I look at this line, if I look at all lines, okay, what makes a difference between letters and words? A space. When I see a space, I know a new word starts. So I need to tell Python something like that, okay? So to do that, for every line, you're going to come in, okay, and we're going to do a new variable. I'll just call it new line. I'm going to split that line blank. Okay, now look what I did. Here I have a line. Here's the line. I'm telling it, take that line and split it every time you see a blank. There's one, there's one, there's one. And store it in a new list. So for example, if I were to print new line, okay, let's not do that yet. Okay, now I have a list where every word is separated in quotes. Now granted, we have this, we'll worry about that later. But every word is separated in the list. Whereas when I had the list before, it was one line was in quotes. Now I have every word in quotes. So you use the split function to break up things, to break up strings. Now we're splitting on a space because that's what a word is, but you could split on anything, a comma, a semicolon, a star. You can split on anything that's in that string to break up your string into pieces. So this alone broke string into words. Okay. Now I don't need to keep printing it because we haven't finished yet. What I want is I want to print each word to the output. So now that I have this that has words in it, I can just say for X in new line what that does. And I get words. All right. Now granted, the last word always has that \n on it. We can take care of that. Okay. But that's how I would split up a file into separate words. If I don't want the \n, then what I want to do is I want to come in here, right? And I want to store, you know, call it whatever you will, inline equals line dot strip. Right? And then you would split the inline. Let's see. Took it all out, right? So you'd want to strip off the \n, and then on that new thing, split it into words, and then walk through that new thing and print the words. So save this little piece of algorithm. You're going to need it for various things, okay? Split is also from Chapter 8. So we've learned rstrip and split from Chapter 8. Now it so turns out that when we did this originally, remember I got every character printed? That's because strings of characters work the same as lists. So if I had, now is the time, for example, this is considered a list of characters. N is in the 0 slot. O is in the 1 slot, W is in the 2 slot, and there's a blank in the slot 3, and you go so forth and so on. It starts with 0. It goes to 1 less than the number of characters in the string. It works exactly like a list does. And this is what they're talking about in Chapter 8. So to me, if you can learn Chapter 7, you've learned Chapter 8. It works the same. And we will do some work on that as well. But that's why it worked within what we were trying to do, because a string is a list of characters. That's all it is. Okay? Excellent. Let's go to another file. I think I have another file out here, a text file. Grades. Okay, here we have some grades. So what we want to do is we want to read in this file and calculate the average and print the average for each student. Notice that it's got multiple lines. They're all separated by commas. Okay, so we want to take this algorithm that we basically just learned and apply it to this situation. So I want a new here. All right, so we're going to read in the file first. And it's a list, so that's read lines. Okay. Now I've got to go through this list and I've got to do some manipulation to get the data out of here that I want, right? So the first thing I want to do is I want to strip all this stuff off so I don't have all the \n's on the end of each of these lines. I don't want that. So I'm going to say that I'm going to call that inline for new line equals, all right, line.r strip. Okay, so that takes off the \n and I don't have to worry about it anymore. Now, okay, every line looks like this. I've got to split this up into grades and name. I got to split it up into its 5 parts. So I'm going to come in here and I'll just call it Stu for student. I'm going to take inline and I'm going to split it. And this one's on a comma, right? Because they're all separated by a comma. Let's just stop here and print Stu and make sure we're getting somewhere. Yeah, okay, so we're getting them split. So now as we walk through it, we have a list of one student with all his pieces separated. And what I wanted to do is I wanted to print his name and his average. All right, so that's what's in Stu is one of these lines. All right. I need to walk through for X in Stu. Okay, well, that's not going to really quite work. If I wanted to add up a total, run into trouble with the first one because the first thing is Jones. You can't add Jones to a number, right? I really want to start with slot 1 and go to the end. When I'm specific like that, I've got to use a range. So I want the range to be 1 and go to the length of Stu. Okay? It'll start with 94, then add those and go. And that'll work for all of them because it's going to start with 1. First thing in here. All right. I'll also need a total variable. Oops. That should be in here because I'm going to do it for every student. Okay. That adds up his grades. All right. I can calculate the average as total divided by what? All right. Well, I know the length of Stu, but I can't include his name, so it'd be length of Stu minus 1. Right? that gets his average. So now I want to print his name and his average. I'm going to print his name. Where's his name? It's in Stu Sub-Zero. Oops. His average. Is this everything we need? Let's look. 2.5 is a little small. What are we missing? What are we missing? Length of Stu. Stu had 1, 2, 3, 4. We went with the Stu minus 1. Stu average. Why is that? Oh, you tell me. Can you figure it out? Look at what these are in. These are in quotes. That means they're not numbers, they're text. So if I'm going to add them up, I've got to convert them to numbers. Okay. Anything in quotes is text. So it's not going to be able to add them up like numbers. Oh, come on. We're X in range. We did that. Total length of Stu minus 1. I did that. Stu Sub-Zero and average. Why is that coming out that way? What am I missing? For X in range, this equals int X. That's exactly what I did. All right, I'm curious. When things like this happen, let's come in here and let's print. Okay, I'll get to your question in just a minute. Let's come in here and print total. Let's see what we've got for total to see where we're going wrong. Total's 10. Well, that's interesting. It can't be 10. Okay. The reason it was length of Stu minus 1 is because there are 1, 2, 3, 4, 5 things in the list, but only 4 of them are numbers that you should divide by. That's why it's minus 1. Okay. Oh, wait a minute. Wait a minute. Length of Stu minus 1. There you go. Oh, come on. Well, let's see. Isn't this interesting? Let's keep going. We'll find it. Why is it always a total of 10? That can't be. Okay, let's keep going. When you do this, let's come in, let's print X. Let's see if we're reading everything correctly. No. What am I doing? We're not reading everything correctly. Oh, because it's not X, right? We're using that as an index. It is Stu sub X. Good grief. Yes, thank you. All right. But when you get stuck like that, you need to do a bunch of prints to print out the data where you are so you can see what's happening. All right, now what do we got? There we go, much better. Okay. Yeah. And that's something you need to remember. It happens a lot where people forget that they're dealing with an index here. Yeah. So make sure that if you need that index, you're using it as an index. All right, excellent. Okay. You'll want to save this type of algorithm too. This is something common that we do in a lot of our homeworks and practices and quizzes and things like this. Now, when you're looking at a quiz or something like this, I might say something like, I have a file that looks like this. Which one of these will read in and give the average of each student? And you'd have to select the correct chunk of code to do that. Notice that the quizzes starting from 3 and 4 and 5, they get a little more involved, a little more to them, a little more coding to them, or recognition of coding to them. Okay. So you want to practice looking and using these types of algorithms so that you'll know. Remember that we did read line, read lines, okay, and for line in contents or in file or whatever. You'll want to know the different ways that we've been reading files so that you can recognize them and you'll know what they mean. Remember, read alone reads in a string. Read lines reads in lists. Okay? Things like that that we'll be working on and concentrating on, and that you will use in your own homeworks as well. Let's look at the homework a minute. Okay, so there's only 3 problems on the homework, and that's because they're a little lengthy. They're not bad, but they're a little longer than the other ones that we've done in the past. Okay, so in the first one, I want you to write a file that accepts a file name and writes the data to the file as follows. So you'll have write file. It accepts a file name. There you go. Okay, remember when I say accepts something, that's what's in parentheses. And all it does is write this data. So you can hard code that in. Copy. So you'll open the file and you'll write each line. At the next one, this is not pure Java. Write this line, okay? And write another one and all of that. You want to write all those lines to the file and close it. That's all you do. Easy enough. When you go to calculate the charge, you're going to read in the file, okay? Calculate charge. It's a file name, an inventory item, and a quantity. In other words, you're going to buy some refrigerators or washers or dryers or something, okay? And what I ask you to do is you're going to search the file for that item. So let's say I typed in refrigerator. You're going to search the file for refrigerator. And I say I wanted 2 of them. Then you're going to tell me what the total charge would be of 2 refrigerators, which is $1,000. And because I wanted 2 of them. And then you're going to deduct 2 from the inventory so that you return the total charge and the remaining inventory. Okay? And I give you the instructions for all of that here as to what to return. All right? So you'll ask the user for the item number, the file name, and the quantity so that you can use it in those functions. So that one's not too bad. You already know how to search through a file. You already know how to split it. This place you'd be splitting on a semicolon. Okay? So that should be fairly easy for number 1. All right? We haven't talked about number 2 yet. Number 3, you're going to write a file, okay, from a list, just like we did over here. Look at those. I've seen those numbers before. You're going to write it to a file, okay, with a write file function. And let's talk about writing lists to a file. Let me close some of these out. Okay. Okay. Oh. There. Okay. So let's say I had some data that I wanted to write. I have one. Let's do out file equals. Okay. And I have a list of names. Write that list to a file. Way would be to do this. Remember, read lines wrote a list. I mean, read a list. Write lines will write a list. Let me tuck this out. Open a new window. What's it complain about? It takes exactly. Oh, yeah. Well, you got to tell it what you're going to write, I guess. That would help. Yeah. Okay. So let's go look and let's see what it looks like. This is a text file. Names. Well, they're in there, but they're all one line. We need to fix that. And apparently I spelled Carol wrong. All right. Okay, so let's write it a little differently. What I could do, all right, let me just put this writes a list. All right, what I could do is I could come down here. And then I could say for what? For X in names. Will not write X. Will that do anything? Oh, gosh, equals. If I open it now, do I have anything? Oh, well, you know what we forgot to do? That was close. Okay, let's go look at it. Looks the same. What do I need to do? Remember, I need to add on a \n if I want every one of them typed in separately, right? I mean, put on a separate line. Run it now, open it. There we go. All right. So it's fairly easy to write the file. Okay. Just don't forget the \n on everything. Okay. So if I'm looking at, I want you to write this file. Now we haven't done 2D lists. We will do that, okay? But just take the first line, all right? You know how to do the first line. If you know how to do one line, just put a loop around and you'll be doing all of them. But we'll worry about that part later, all right? And so you'll just walk through and you'll write all these things. Now notice, okay? Notice that these do not have quotes around them, so they're numbers. And you cannot write numbers to a text file, so you'll have to convert those to integer, to string, to write those to the text file. Right. But writing is very easy. All right. And as I said, you don't know yet what to do for number 2. Right. On chapter 8, because it's fairly small and we've really done a lot of chapter 8 already, and it's duplicative of what we're doing in 7, I'm going to post some video. I think there's only one video for chapter 8. It's not that long. Okay, it will go over R strip and split again, and a couple of other things about strings. So I'm not going to cover chapter 8 in a lecture because it's such a short one, and I'm going to give you the videos. Another thing is in chapter 6.4 on exception handling. I'm going to put up videos for that. It's a real easy topic. I've asked you to do it on one of the problems, number 1, when I say you're going to want to do exception handling. And those videos will show you how to do that. It's very easy, okay? The others don't require that. So I'm going to put up videos for a video for 8 and some videos for exception handling from chapter 6. And that will revisit some of these things that we've done already. Okay, the only thing that we won't have done was slicing, and we're going to get to that. Okay, I guess that'll be after spring break, but it's very similar to things that we've already done. All right, I'm thinking that after spring break, I might just put up videos on Tuesdays, and then we get together on Thursdays. Does anybody have any major issues with something like that? And you don't have to tell me right now if you don't want to. You can send me email and express your thoughts. If anyone has any problems with videos on Tuesdays, and then we meet on Thursdays and we do problems. things like that, or we talk homework or whatever. Okay, all I was saying was I'm thinking about after spring break that instead of meeting on Tuesday and Thursday, I would provide videos on Tuesdays and then we'd meet on Thursday. And I was just wondering if anybody had any major problems with that. Office hours would remain the same and lab hours would remain the same. I just think it might help if you saw the videos before we came and talked about all these things and some problems. Maybe not. So you are welcome to let me know your thoughts. You can send them to me email or express them now or whatever. But think about it over spring break. I'm thinking that when we come back, Tuesday will just be videos. And then on Thursday, we would actually do problems that were from the content of those videos and everything. Okay? But if that doesn't work for everybody, just let me know. All right? Okay. So, what we have managed to do. Okay, so someone sent me an email. I didn't get an email yesterday from anybody. So if I don't, then send it again. Or you know, come to office hours today and let me know what your question was. I did not get any emails from anyone. Okay. Okay, so today we did lists. We know that they're mutable, okay, that they're in brackets. They can have any type of data. All right. We know how to do read lines. We know how to do write lines. So we can read and write files with lists. All right. We know that we basically have indices for lists. They have an index and a position. And we can use a for loop to walk through a list. And actually, I guess you could use a counter while, but we won't worry about that. Okay. And in the homework, when I say walk through this list, every time I say walk through, you should be thinking of for loop. That's just the way it is, okay? So we have these things from chapter 7 that we did today, all right? There's still a couple of things in chapter 7. We haven't gone through everything, but we'll, I'm going to put that up in videos for Tuesday when we come back. So you'll have that information. And I'll try to get them up fairly early, okay? So you'll have that information. So then on that Thursday, you can ask questions about your homework or we can work problems or, you know, other things that I've got planned, things like that, okay? Does anybody have any questions about anything? Well, I'll be at office hours. I'll hang around here a little bit as well, okay? So I'll have office hours at 11. Y'all have a good spring break. Don't go away and get sick, okay? Take your mask or something if you're going to go somewhere on spring break. But y'all be careful, and I'm sure I'll be talking to you when you come back.